do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. Thanks to our partners for helping us bring you the best developer pods each and every week. Fastly.com, Fly.io, and Typesense.org. Okay, here we go.
So today we have Michael Quiqley from NetFoundry joining to talk about Zero Trust. Michael, how are you doing?
I'm good. How are you, Natalie?
I don't trust you. Are you sure? Are you sure that you're good? How do we establish trust?
I am actually. It's a tricky one. That's the heart of the matter, unfortunately.
Yeah, I'm doing good as well. I'm trying to do good as well. What is Zero Trust?
So Zero Trust started with this. I mean, I'm not exactly sure when it started, but it sort of became popular with this concept that came out of Google called Beyond Corp. So they started this big initiative, and I don't remember the exact time frame. I want to say it might have been, maybe let's call it a decade ago, something like that, where they had this Beyond Corp initiative, and it was about not considering the difference between LANs and WANs, kind of like where you are in terms of physical security being related to how your network security is postured. So a lot of times a while back, we would have configured access to things by I'm in a corporate office or I'm in some physical location where I've got specific network access to something. Zero Trust was sort of about getting rid of that concept and going to, it doesn't really matter where you're physically located and what your underlying network is, treating the security posture differently than that. So using certificate authentication and crypto and things to strongly identify folks that are like whoever's using your network resources, like actually securing them that way. So that was sort of the genesis of the Zero Trust concept.
Was there anything specific that kind of created that? Was there some big DEF CON incident? Was it just a growing pressure?
I think it was more of a growing pressure for like remote workforces and that kind of thing. I think people, this was pre-COVID and all that sort of thing. So I think people were just, starting to really get into not having to be tied to an office and that sort of thing. And it made sense. And I think it was sort of a, how can we make this work better than it had worked previously? Because, in the old days, you'd have, VPNs and you'd have facilities to sort of make you act like you're on a local network and some of those sorts of things instead of like actually solving the real problem. So I think Zero Trust is sort of a response to that.
Yeah. And how did the adoption go in the early days?
I think the adoption is still, in the early days, I think it was sort of a pipe dream and a little bit of a, probably worked for a lot of folks at Google, or it was, certain segments of the Google workforce might have been using that sort of Beyond Corp approach. I don't actually know, I wasn't there, but I think, it's been a slow adoption over time. So I think a lot of the VPNs and some of the other styles of securing things are still, still very commonly used. And I think there are progressive organizations and people that are really starting to, get into Zero Trust and start using those tools. There's also better tooling coming out. There's a lot of, infrastructure that's better than it was a while back. There's also, I want to say that the White House might have had some sort of initiative around Zero Trust. Like that's actually a talking point in terms of I think that's a thing that people are sort of being, exposed to more now because it's sort of a commonly used talking point about cybersecurity and some of those kinds of buzzwords.
Okay, that's nice to be up to date with the times.
I think that's reasonably accurate.
And then how would you describe the world of Zero Trust these days?
There's a lot of really interesting products out there. I mean, I'm obviously biased to the things that I work on. I think we solve some of those problems in especially clever and innovative ways, but there's a lot of really great tools out there now. There's all kinds of ways to solve the Zero Trust problem. Some of them look more like traditional VPNs and some of that sort of thing. And then on the other end of the spectrum, we have tools like the stuff I'm working on, which is OpenZD and ZRock and some of those things that take Zero Trust in a slightly different direction. But the tooling in general is getting a lot better. I think it's, one of those things that people understand it more now than they did a while back. So, as people understand things more, the tooling gets better and people, start iterating on tools and conceptually they improve. So tell us about what is different in your approach. So when we started working on ZD, I want to say it was maybe 6 or 7 years ago at this point, probably about 6 years. We started with a sort of whole cloth solution to this. We actually started with a proprietary product that we sort of built a wrapper around. It was this closed source thing that was used by the Department of Defense and some of those kinds of people to do spread spectrum like security and some of those kinds of things around securing data in motion. We kind of built that and added some additional layers of security on top of it. And then we started looking at the problem from a sort of a holistic perspective, like how do we want this to work? And what we ended up with was sort of a network overlay that doesn't sort of piggyback on top of IP in terms of like IPsec or WireGuard or anything like that, where it's actually re-encapsulating and encrypting the data. We kind of, I mean, conceptually what we built is closer to something like Tor, where we have, a mesh network that we call the overlay, and then the all of the underlying IP networking, like whether it's WAN links or whatever it might be, we refer to that as underlay. So all of the overlay is basically running in user space, and we've got this mesh network of routers that has smart routing, has its own sort of addressing protocol built on top of it, and layered into that from the very beginning is strong cryptography and strong security around identity. So it truly is zero trust from that perspective, in that you can't really do anything on the network without having strong identity in the loop. But that let us do some interesting stuff where we can sort of tailor the addressing model and the naming model and the policies and all those sorts of things at a user space level. Even the routing protocols across the mesh, they basically are running in user space. And you can reroute traffic. You can say, I only want this traffic to go through these links. You can control costs across those things however you want. So in the early days of a lot of this stuff, I was working on the underlying fabric, the mesh networking, and the architecture around that. And then on top of that, we've layered, various edge protocols and higher level constructs that allow you to embed this stuff in the applications. And that, I think, if we're talking about like an elevator pitch for this, I think the main thing that we like to talk about in terms of like how we would explain OpenZD to people is that it's more of a programmable network. So we really come at it from the perspective of, we have SDKs and we've got infrastructure that's designed for programmers to embed this stuff into their applications. So rather than sort of being like a network layer thing that you use like a VPN or you use as like some sort of bolt-on your application to sort of try and secure it and bolt zero trust to it, I think our ideal use case is we want people to take our SDKs and embed this stuff directly into their applications. So that's the main difference, I think.
You talk about meshes, and I'm thinking of Istio and similar meshes as well.
Yeah, there's a lot of overlapping concepts. In fact, we've got people on our team who are working with OpenZD and actually in Kubernetes and that kind of stuff. And there's a lot of things we can do with our mesh that I think are interesting in that kind of a managed containerized sort of environment. So yeah, there's definitely overlaps there.
And so does it also do things like logging and monitoring while at it or tracing?
Yeah, we've got all those things, metrics, all the things you'd expect to have in a network like that. Yeah, we do those things.
So it's a sort of a full stack mesh.
Yeah. I mean, and the nice thing about the design too is you can take whatever layers make the most sense for what you're trying to do. Like we generally ship the entire stack to customers and they use the whole thing, but you could use just the mesh if you wanted to. You can, and then going up even higher, since now that ZD is starting to become mature, I've sort of pivoted my work and I work on an open source project called ZRock now. And ZRock was sort of the name is, you can kind of tell what it was inspired by just by the name, right? Most people will be familiar with ngrok. I kind of had I was basically directed like, go figure out what something like ngrok would look like on top of OpenZD. So I built ZRock, and ZRock, one of the cool things about ZRock is that you look at tools like ngrok, and it's awesome that you can share a private resource on a public URL and let anyone use it and don't have to open any security holes. Like all those things are great. But one of the cool things about ZD is because we have this overlay network and we control the addressing and it's all zero trust, we can do peer-to-peer across that network. So you can, without requiring any of the peers to expose themselves publicly or anything like that. Like all the peers can remain quote unquote dark, but we can still have peer-to-peer communication. So that lets us do things like private sharing, where we can say, I want to share a network connection between two completely dark peers, and that there's that traffic will go across the overlay across the internet, but none of that's exposed to any of those things. Like all that data is end-to-end encrypted. It's all zero trust under the covers. So that's one of the things that's really cool about it. So ZRock ends up becoming like a really good use case for showing people how you can use something like ZD to build things that you couldn't otherwise easily build.
And how does all this fit with Go?
So that's an interesting story. So when we started building ZD, it was almost accidental that we ended up on Go. And I couldn't be happier that we chose. I mean, Go, I've been doing this a long time, and I would say that Go has replaced a lot of other programming languages for me.
Like what?
Oh, anything that I would have done in Java 15 years ago, I would do in Go now without even missing a beat.
How did you come to hear about Go? When did you first try it? Why?
That's part of the story. So when we started building OpenZD, one of the things we were looking at was we've got this mesh network, this overlay, and we want to obviously make it as performant as we can. So one of the things we were taking a look at was what kinds of protocols could we use to implement this mesh. And at the time, we were big into Quiq. We were taking a look at Quiq, Quiq. It's a alternative HTTP style protocol that Google put out. And the main implementation that you could find on the internet of Quiq was written in Go. It's Quiq-Go is the library. It's still, widely used. So we accidentally started building ZD in Go because of Quiq-Go.
Interesting.
Yeah.
So that was the reason. Were there other languages that you were considering and you said, Quiq-Go is more important?
I want to say an early version of some parts of ZD that I had worked on back then were probably written in JavaScript. So it was Node. We actually started parts of it with Node. And as soon as we started messing around with Quiq-Go and started getting into, there were a couple of us working on this stuff at the time. As soon as I started working in Go, I was just like, this is it. It took me, I'm sure a lot of people have very similar stories with Go adoption. It took me, not a lot of time to understand the language, but then some of the idioms, like there's a lot of, when you're building a mesh router or anything like that, there's a lot of complicated state in that. And there's a lot of complicated concurrency in that. And some of the patterns in Go took me a little, I'm not, been using mutexes and semaphores and things like that for years. Some of the Chan and some of the concurrency patterns in Go took a minute to get used to.
Until you stop writing JavaScript in Go.
Yeah, stuff like that. So, and I wouldn't say that I'm still perfect at it. Like occasionally, I need to slap a lock around something, just like it just seems like the right way to do it. But
feel safer.
Yeah, feel safer, exactly. So yeah, that's how we ended up in Go. And I wouldn't, in retrospect, I wouldn't change a thing.
Mm-hmm. Nice. And then how was the community adoption? Did you start speaking with Go developers, or how was your interaction with the community?
We're actively working on that stuff. So that's I think like a lot of open source projects, that's always it's a challenge to get the word out and get people to understand what you're doing. I think one of the things that's tricky for us too is that ZD is a fairly different in terms of like what we're doing philosophically and like how we think about overlays and security and that sort of developer first approach. It's hard. It can be a little hard to explain to people. Like I think when people think overlay networks and zero trust, they think like VPNs, and they think they've sort of got a bunch of concepts already in their head, and they're used to thinking about these things certain ways. So we kind of have to say, well, like that, but different in these ways. And it can be a little bit of a challenge. So I think that's one of the things that we're actively working on, is trying to figure out how to get the message right. And, like a lot of people that work in tech, like we're not always awesome at marketing. Like sometimes we struggle with these things, and just like we're not awesome with documentation all the time. Like it can be a little tricky to get that going, but we're definitely, things are picking up. We've got a lot of great customers. There's a lot of people we're starting to get a lot more attention, basically.
Yes, you can always try to speak to the heart of Go developers, saying that you wouldn't write Go syntax the Java way or the JavaScript way. So same logic, don't.
Yeah, absolutely. And I think, if you look at our Go SDKs, like we've got I kind of think of it as there's OpenZD and then there's Zrock layered on top of it. And Zrock is kind of a really good way to sort of understand at a high level, like what's going on with some of the stuff. You can start with that perspective and sort of drill into it. So there's a, OpenZD Go SDK, but there's also a Zrock SDK. And the Zrock SDK, like if you're a Go network developer, it's net.con and net.listener at the end of the day. Like it couldn't be any more simple than that. There's a couple of extra lines of code to sort of establish identity and that sort of thing. But beyond that, like dial and bind, and you're kind of, you're there. Like it's basically traditional net.con and net.listener, and you've got a working network, and everything's zero trust and it's secure, and you're peer-to-peer and all those kinds of nice things.
Okay. So you say that what you do is different from some of the traditional zero trust. So let's talk, what is a traditional zero trust architecture? What are some components there, and what is different with you?
Sure. So I mean, and I could be wrong in this perspective, but I feel like when I think like traditional zero trust,
It's not the best word, but we,
sure, no, I get what
in
you're
the
getting
lack of
at.
a better word, we go with that. Yeah.
Yeah, I would think of things like Zscaler.
Hmm.
So Zscaler is a commercial product that you can buy that I believe fairly closely mimicked the sort of Beyond Corp, the Google approach. And I haven't spent a ton of time working with Zscaler, but my sort of naive understanding of it is that it's more or less sort of a network proxy. So a lot of these traditional zero trust products kind of want to be a proxy that mediates security for you and that deals with identity and deals with validating that your users are who they say they are and those kinds of things. We're different than that in that we establish an overlay network, like a true overlay network that's that mesh network, and then endpoints can sort of sit wherever they are, right? So you don't go through a proxy. You're basically connecting to that mesh network. So and that lets us do all kinds of things with citing resources wherever they need to be on that mesh, and we've got all kinds of fancy load balancing, all that kind of stuff. But it can be dealt with at the right level of abstraction for the applications you're working with, right? So your applications, you can put resources wherever they belong. You can do the same thing with a proxy, but it's just sort of, it feels different and acts different at the end of the day. Does that make sense?
I don't want to sound like a ChatGPT, but if you were to summarize
Yeah.
the core parts of it, like your average zero trust architecture, what would be those components?
I would think, I mean, again, these things they all look a little different these days, but I would say the average zero trust implementation is probably some form of a proxy. So that's what that looks like. And you can
move that responsibility around basically.
Yeah. You can put that proxy in that border wherever you think it makes the most sense.
And what are some misconceptions or misunderstanding or like wrong usage patterns of zero trust, if that exists at all?
I think, honestly, I feel like one of the anti-patterns of zero trust is trying to treat it almost like a VPN.
Mm-hmm.
And I think that's one of the things that we try very hard to sort of steer users away from is rather than, you can take our components. We've got a really powerful tunneler. We've got resources that'll let you get down to layer 2 and layer 3 and those kinds of things and let you treat what we do almost like a VPN. But I kind of see that almost as an anti-pattern. Like the right way to do this is to embed that zero trust capability, that border directly into your application code. The less optimal way of doing it would be to sort of try and bolt it on through some sort of gateway or something like that. That's, to me, feels a little bit clunkier and a little bit more disjointed.
Does the use of zero trust components in general make at all ISO certification for security more complicated, simpler, or have no effect at all?
I don't actually know. I haven't been through a certification process like that, so I don't really know.
Mm-hmm.
Yeah, I don't have a good answer for that. So I don't know.
I can definitely see the value of using that on the technical side, but usually you do security. If you spend a lot of focus on security, you're probably going to display that for others to know that this is a checklist that they mark and are able to use. So
right,
yeah, interesting.
Yeah, I would assume like most certification processes, you got to sort of go through and vet all the components that are involved and that kind of thing. So yeah.
And let's say you have a system that uses whatever security measures and you want to introduce zero trust into that. How do you go about that?
It depends. If these are things where you don't have access to source code or willingness to change source code, there's all kinds of ways to add zero trust layers on top of things. So for ZD, we've got what we refer to as a desktop edge or a mobile edge, which is something that sits, it's a piece of software. It's more or less sort of an end user facing daemon, or in the case of like a headless Linux system, it's just sort of an actual daemon that mediates connectivity into the overlay. And from there, I mean, your application just treats the local ZD endpoint as if it was the remote resource. So it's just a matter of configuring things in a way that makes sense. So really the non-zero trust, non-secure traffic doesn't leave your local host. Like when it leaves your local host, it's going through a security layer through ZD, more or less.
Does this affect in some way latency in the system?
Yeah, I mean, I think it's physics that if you add extra machinery in the middle, it's definitely going to impact performance. The interesting thing about that, though, is throughput, latency, those kinds of things. You would be surprised at how little impact that actually has in practice. Like it's actually, I mean, we're not fully there yet, but we've worked very hard to sort of make these things perform well and not be overly latent. Yeah, there's extra connection setup involved and connecting an overlay. Like you're gonna have to talk to a control plane that you wouldn't otherwise talk to.
Yeah.
But you'd be surprised that in practice it doesn't really make that big of a difference.
Good thing you're using Go.
Yeah, no, and that's yes. The performance of our Go code is very high for a relatively low cost. So to get good quality performance out of code, Go is a great choice because the overhead of getting there to me feels lower than C++ or something like that. So
the generics affect your code base at all?
One of the developers who's currently working on a lot of the low-level stuff in the mesh layer now, it's done a lot of work with generics. But when we built most of OpenCD, generics wasn't a thing. So I think there are layers that we're sort of adding some generics to because it does actually make a difference. I think some of that stuff is some of the persistence layers and those kinds of things. There are some we're using bbolt for a lot of storage. So bbolt or bolt is like in etcd and it's part of Kubernetes basically. So we use that as a persistence layer, and we've got a whole bunch of infrastructure around that that does use a bunch of generics and things. So, but I don't think there's a ton of generics in OpenCD as a whole.
Is there any prediction that you do or plan to do something with usage of AI and like recognizing potential good, bad, recommended behaviors or any other use of AI?
So one of the things that we had talked about a lot, I think I mentioned it earlier, is the smart routing capability. So we have this overlay network and there's connections in all directions, and we've got this mesh. And we have, a sort of a basic implementation of what we call smart routing. And that's about, rerouting traffic through to a different path if there's a better path available, or rerouting around damage and some of those kinds of things. There's a couple things that I think could pull AI into the mix. We're talking about multi-tenancy and that, we've got this big data plane and we want to be able to allow multiple customers to share large amounts of resources, right, on the overlay network. So we're having a big, giant, well-provisioned mesh, and then we let lots of customers use that mesh. That's one of the things that's a discussion point. And then our smart routing implementation could very easily use statistical learning or ML or something along those lines to sort of make smarter decisions around optimization potentially. So I think there is an aspect of what we're doing with that overlay that could benefit from that kind of an approach.
Have you seen that at all? Is that some trend that it might be coming?
It's mostly just something we've talked about in discussions about the product. I don't think there's anything necessarily, there's no mandates or anything like that coming down the pipe. But we it's not a huge area of focus, but it's something that we've talked about a bit as a team.
And generally it's a question about the ecosystem, and it's obviously a very big question that on something that moves way too fast. But is this a trend or a tool, a focus or direction is a good word, that the zero trust ecosystem is going towards?
I don't think I've seen much about zero trust architectures in AI at this point. I think most zero trust implementations are mostly trying to get people to understand A, the need, and B, the architecture and how you kind of adopt these things and getting a good foothold for what they do. I don't know that, by nature, a lot of these things are going to be tools to help you optimize a lot of what's going on. I mean, I do have some interesting stories about that in terms of optimization stuff that we've done along the way, but
that's very interesting.
Yeah. So as a side note, one of the things that I worked on a couple of years ago was one of the things that our previous closed source product did was it did a really good job of sort of being a WAN optimization layer. So you could send traffic through it and it would, in some cases, outperform like a generic TCP connection by a good bit. So sometimes 2 to 4 or 5 times what TCP would do, especially on like a poor performing link, like think, other side of the planet, that kind of a thing, where big long link with a lot of packet loss. So one of the things I worked on was a library I called Dilithium. And the overall product, I just called it, apparently I was on like some sort of Star Trek kick at the time. I called it Transwarp. And it was to build a user space protocol that acted like TCP. So the goal was to have the same reliability guarantee, to have the same sort of look and feel as an end user as something like TCP, but provide a better performance than TCP. So I actually was able to get to a point where on lossy links, especially certain, it didn't work in every case. It wasn't always faster than TCP, but in a good handful of cases, we saw 2 to 5 times faster performance. The main thing that I think helps in those cases is it's all about, if you look at, under the covers, TCP is doing packet loss mitigation. It's trying to look and say, hey, I sent all these UDP datagrams and like things didn't arrive, or things have gone missing. And there's certain fairness heuristics built into TCP where if you've got 100 TCP connections that are all sharing an oversaturated link, they're all going to try and back off and be generally fair to try and make sure that all of the TCP connections or whoever else might be using that link is getting a reasonable slice of the available bandwidth. Well, the protocol I built didn't care about that. It assumed that the only thing that was going across that link was this dilithium connection. And it didn't try and be fair or do anything like that. It just tried to saturate the link as much as it possibly could.
And because it was for those, it worked best for the edge cases where it was, for example, far, then it also means it was not very common. So it was not competing too much. So it's okay, kind of. It's okay greedy.
Yeah, exactly. And it was designed to be used in cases where it was okay to be that kind of greedy.
Mm-hmm.
So that, I believe that's still available as a transport option in ZD. So I think it's still, I don't know if I haven't looked to see if anyone's pulled it out, but I want to say you could still set up a transwarp mesh and have that protocol. And again, there's certain cases where I think it might perform less well than TCP. Like I think local host, like there's a couple places where, the fact that it runs in user space, there's some buffering issues and things where it doesn't always perform as well as it could. But for certain kinds of links, it's definitely, you'll get a pretty good performance boost over TCP. So, and that repository is in our, if you go to GitHub/OpenZD test kitchen, we've got a separate sort of GitHub group. There's I believe it's there. There's a dilithium project. It's all an open source, so people could check that out.
Taking notes of all the things you're mentioning, and this will all be part of the show notes with links. So anybody wants to go and check this out, you will find this in the show notes.
Yeah, if there's any links that you don't find or anything, let me know. I'm happy to help out with that.
Yeah, it's interesting when you say that. I'm thinking of a project that I did as part of my graduation project in university, where it was somewhat similar, but I like finding comparisons between two fields. So that one, when you do sampling of signals, you have to follow the Nyquist rule or theorem.
Yep.
And then that was specialized. My focus was on the sub-Nyquist when it's a very like dead and empty. Forget all the terminology already, but when it was in sub-Nyquist, then you can change the behavior also to be more greedy. So it's nice to see the same pattern goes over everywhere.
Yeah, absolutely. I'm also a musician and I do much audio engineering, so I'm familiar with Nyquist. Yeah, I get that. So
yeah, what is your favorite theorem as a musician?
My favorite theorem? Mm-hmm. I don't know that I have a favorite theorem. I don't. As a musician, I probably don't have a favorite theorem, but yeah, I'm familiar with Nyquist and sampling and that kind of stuff. So
yeah, identity and access management and audit log and so on. Is this something that is also common in Zero Trust?
I think different products approach it in different ways. Mm-hmm. I know for us, so like any business, we have to find a way to make money. So we kind of break our universe internally into all of our products are open source projects. So we don't really have special things that we sell for more money or anything like that. We do primarily, our main bread and butter is hosting OpenZD for people and running it in a professional way. So I know we call that Cloud ZD. So we've got OpenZD and Cloud ZD. And I know that Cloud ZD does have, there's audit logs and all that kind of stuff for all those things. So, and the way that access management works in ZD, we have a policy system. So identity, there's various, all the concepts you'd expect to be there. There's identities, there's services, and those things are controlled, like who can access what is controlled by policies. So it's very much a rules-based access control sort of thing.
In your cloud solution, are you using ZD?
Yeah. Oh, yeah. We run the exact same code that we ship as open source. Like there's nothing, we haven't added anything new to it or anything. There's no special sauce or anything like that. It's literally the open source project.
But are you also users of it yourself? Like, are you trying it once from the user side and once from so you experience all the pain points?
Absolutely. So our main, I think one of the people on the team, I always use the old dog fooding analogy, like eating your own dog food. It's like, no. we drink our own champagne. Like it's a better, right? So our champagne drinking is that we used Slack in the old days. We switched to Mattermost. So we use Mattermost, and our Mattermost is Zetified. So the only way it's completely dark, and the only way you can access our Mattermost is through Zeti. So every day, all day, when our internal communications are all through Zeti.
So every time there is onboarding, something in the documentation gets better.
Yeah, that's the hope. So documentation is hard though.
Yeah, for sure. Although I guess it's one of those things that ChatGPT can also help with. Here's what we do. Explain this better.
Yeah, I've actually been not just ChatGPT, but I've been running a bunch of like local LLMs for various writing tasks and stuff, and that stuff can be very useful.
What is your favorite LLM these days?
I'm still like one of my favorite LLMs is Karen the Editor. There's an LLM called Karen the Editor, and it's basically an LLM that was trained to edit text. So I kind of almost use it like a Grammarly kind of thing.
Interesting.
Yeah, and I don't often take the text right out of it, but I'll look at what it suggests and I'll sort of rewrite that, because I very much like to sort of like do my own editing as much as possible. But it's good to sort of diff what I wrote and what it thinks, and like what's the I'm sure I could just use something like Grammarly and have it be a little slicker for me, but I kind of like the DIY ethos of doing that myself. So
yeah, interesting. I never heard of that one, but it's also in the show notes.
Yeah, okay. Yeah, Karen the Editor. Yeah, there's on Hugging Face, there's a user called The Bloke that anyone that uses open source LLMs will probably be familiar with. He has a 4-bit quantization of that model that I use all the time. So
what's a good practice of integrating that with DevOps pipelines?
Good practice of integrating that with DevOps pipelines.
I guess you have internally some DevOps pipelines. You mentioned you're using generally Zeti internally, so maybe something that you can share that you are doing internally.
I mean, so internally, we've got a pretty extensive smoke test. So we do have, there's actually, as a side note to that, there's another open source project that we kicked off a while ago called FabLab, FABLAB. And it originally stood for the Fabulous Laboratory or something like that. I forgot. It's taken on a life of its own, but it's basically DevOps tooling for Zeti. And we've got a number of smoke test components and things like that run as part of our CI. So we do a lot of CI stuff with Zeti internally to test it and make sure that, smoke testing and those sorts of things. So Zrock as a project sits on top of Zeti. So it's what we call a Zeti native application. So it's about... And the thing that makes that interesting is it's about automating the control plane, and in addition to just using Zeti as a framework for communication. But there's a bunch of CI-related bits that we very much run Zeti and host Zrock on top of it. So, and that's a service that users can actually go to zrock.io and sign up for. Like it's just like you can sign up for ngrok, you can sign up for Zrock. It's the same sort of idea. But that's all running in production. It's running OpenZeti, and it's basically there's some CI components to make sure that we're always up to date and that sort of thing.
How do you measure if this is doing a good job?
How do we measure?
Zero trust. Yeah, like what would be even a KPI for zero trust other than we're not getting hacked?
Right. Probably, I would imagine usage. Right. So I would imagine if you're an organization and you kind of wanted to measure zero trust uptick, like how much uptake there is for zero trust, the number of services, the number of endpoints, the amount of traffic, things like that would be good indicators of like the success of that. Versus how much traffic is not going through a zero trust network or through a zero trust endpoint. Like that differential might be a useful thing to measure to know how you're doing with that.
Maybe also delay or latency before and after.
Sure. Like I would think of that as more like an operational metric, like how well is the overlay performing. And I would imagine there are cases like with the whole transwarp dilithium thing, there's cases where an overlay could improve the performance of what you're doing. But I think in general, most people aren't using them to try and make things faster or better. I think it's more about it's physics. Like you're going to put your bits through more CPU. Yeah. It's going to take longer.
I mean, it's a trade-off that probably is okay to have also. And just this is a question in the context of what would you measure and not like how is it good or bad? It's sometimes we have to do that. Yeah.
Yeah, absolutely. I mean, operationally, CPU utilization, like all those normal things are all like good things to measure in terms of performance. So
I'm trying to understand now if I want to do tracing.
Yeah.
and all the tunneling and like finding smart paths happening, what would tracing look like? Would you be able to see the lifespan and location span of such a request?
I believe we've got the tooling to do all of that. I know that that's one of those things that's looked different throughout the life of ZD. Like things have gotten better, and responsibilities have moved around. That is a tough problem because there's a lot of layers to something like this. It's going through an overlay. There's various underlays where you're going from overlay concepts to underlay concepts, like overlay concepts being like this identity and this service, and underlay concepts being like these pairs of IP addresses and these ports. Like there's a lot of translation that needs to happen at various layers. And I do believe we're at a point now where, having run this stuff for production customers for a number of years now, we've had to solve enough problems and drink our own champagne enough that we can those tools.
I see what you did there.
Yeah, those tools are reasonably mature at this point. ZD in general is still pre 1.0. I think we're pretty close to getting a 1.0 out the door, but we're still at like 0.30 or something. So yeah.
There will be champagne at 1.0.
Yeah, but I know back in the early days, I had built some tooling that would let you look at just like you would do like a TCP dump of an underlay network, like taking a look at like what packets were there. There I don't know if it probably is still there, but there was tooling to do the same thing for overlay concepts, like looking at what flow control is doing and routing and some of that kind of stuff, and how things are packetized. So, but just like most traceability things, I'm pretty sure we can assign a UUID to a connection and trace it all the way through.
Yeah, it's always interesting.
Yeah, those are tough problems to solve.
Yeah, for sure. It's those are very interesting challenges that you are having, and I guess you are accepting contributions to the open source repos always.
Absolutely, yeah. No, we love external contributions. Like that's one of the things I'm very happy about with all of this, is that we're very committed to open source. Like we're very much an open source first company. It's one of my favorite things about the stuff that I get to work on. Like I feel very fortunate that I'm able to work on open source full time. Like that's amazing. So yeah, I mean, we're a bunch of real people who are sitting around and working on this stuff, and we do keep track of stars on repos and stuff. So every time a flurry of stars comes in, there's a lot of us that get pretty happy about that. So we always appreciate those things. Anytime anyone submits a PR or something, we're like, oh my God, there's somebody from the outside world submitting a PR right now. Like it's always really nice. So
can anyone submit a PR? Is there some guidelines that you're asking to follow, or is this pretty easygoing?
I think it's pretty easygoing. I think we have contribution guidelines. I think you have to. I think there might be a little form or something. Like a lot of projects, like I think there might be a form or something you have to fill in, but it's relatively straightforward. There's not too much to it.
And Hacktoberfest is around the corner.
Yeah. No, that would be amazing. One of the things that I know I'm part of my world right now is we do have that Xerox SDK, and that's sort of the easiest possible way to sort of get yourself programming on top of something like OpenZD. You can sign up for a Xerox account, download take the SDK for Xerox as a dependency in a Go project, and have a working application in 5 minutes. Like it's super, super easy. We are rolling out SDKs for other languages and stuff too. So I know for a fact we're working on Python and Node right now. So and I'm sure we'll probably roll out something in Rust, and I'm sure we'll hit some of the high points there. But I mean, it's actually a really good time to get involved with some of that stuff. It's really easy to build very powerful peer-to-peer stuff. The example I built for Xerox is sort of I called it a paste bin, because I when I first started coming up with this, I was thinking of it kind of like a paste bin sort of thing, but distributed. It's probably not the best name for it, but it's basically a buffer that you can work with between any pairs of machines. Any enabled Xerox machine, you can shove data through it like it's a copy and paste buffer. And it's like it's also the SDK example, and it's the core of it's like 3 lines of code on both the server and listener side. Like it's trivial to get your head around some of that stuff.
And if I start with the Go SDK, what is kind of the out of the simplest box things that I can look at?
In terms of like the Go SDK, like what are the? I mean, it's at the end of the day, it's pretty straightforward. A lot of the SDK itself sort of wraps the identity concept. So all of the things that you would have to deal with that are complicated, like the identity and the cryptography around it, and all those things are sort of already wrapped up with a convenience wrapper in the SDK. So all you have to do is call the right API calls. And you're basically, you've got all your identity and all those things working. And then from there, it literally walks and talks just like a regular Go server or client. Like it's, netcon, net listener, and those things act just like they would act if it was just plain TCP or something along those lines. So it's pretty, if you're familiar with like writing a network server or writing a network client, like it's pretty much the same thing, but it goes over an overlay and it's all secure and zero trust and those kinds of things.
Lots of questions and lots of interesting learnings for me here.
Yeah.
What is your favorite protocol? You keep saying TCP. Is it TCP?
No. What's my favorite protocol? I don't know. I've done some of the more interesting things I've done in my career have involved building custom protocols on top of UDP.
What was the customization doing?
So in a previous life, I worked on a product that was telepresence oriented. So I actually have a patent for embedding haptic data into live telepresence streams. So
what is haptic data?
Touch data.
Aha.
Right. So like controlling devices and things like that, things that involve touch, and then synchronizing that with audio and video so that it's an immersive experience. Actually, I was the author of a patent along those lines.
I'm trying to imagine what does it do? You touch and then it touch the screen and then it makes sounds. Basically, a device
on the other end, basically.
Mm-hmm.
Yeah. So it was used in the entertainment space, but it's the low level implementation of it I built, and it at the time this was pre WebRTC. So this was before WebRTC was a thing, which is built into every browser now, and it's a good C++ library for doing that sort of stuff. I had to build my own engine that was basically audio, video, more or less like a Skype or a Zoom. Like I had to actually build that from the ground up, which sounds like a lot, but the nice thing about doing that was I was able to cut corners because I didn't have to worry about interoperability, right? So I didn't have to worry about like conforming to standards or anything. I could just say, I'm going to use, VP8 and I'm going to use this audio codec and not worry about negotiations or anything like that. So I was able to build something that let me save some time because I didn't care about interoperability, but that did allow us to sort of, and one of the things you have to deal with when you're writing a audio video client like this is you have to make sure that the lips move the same time that the words come out, like you hear the audio. So there's a lip sync thing that has to happen because generally the audio and video streams show up independently, like they're separate UDP streams. So you have to synchronize those in the client. Like you actually have to play them out at the same time. So synchronizing arbitrary streams of data is just a matter of building a synchronization primitive that lets you synchronize more things.
So you were building this type of synchronization on top of the UDP, basically.
Yeah. So again, like telepresence is always about UDP because you need the lowest possible latency, and you also versus something like TCP, TCP will hide the fact that there's packet loss from you. Whereas UDP, you're dealing with low-level datagrams. If you lose packets. So the way that you tune, if you're building like a telepresence client, the way you react to packet loss is you're going to tune a codec or change your transmission rate. You're gonna change things in a different way than you would for like a network protocol because you're concerned with latency.
Yeah, and you can interpolate, and that's okay.
Yeah, exactly. There's things you would do in that domain that you wouldn't do in other domains. So it's one of the things I'd like to work on at some point. I'd like to actually do some telepresence stuff on top of overlays and things like ZD. I think so. One of the cool things about ZRock is it lets you share things really easily without having to worry about like, do I have to open ports or any of that sort of stuff. I'd like to, it would be really cool to do a self-hostable peer-to-peer telepresence setup on top of something like ZD. Maybe it's something I'll get to work on in ZRock at some point. I don't know, but I would probably enjoy that. So
interesting. Yeah. There must be some interesting usage in here for interpolation and just using UDP to make it faster.
Yeah.
Averaging some data. We have to brainstorm later.
It's still a thing in our roadmap to talk about, like, the mesh network that we build now is all about, it uses TCP connections primarily, like, so, TLS encrypted TCP connections. But it's still very much on our roadmap at some point to get around to renewing the work I started with Dilithium and talking about UDP-based transports and things for ZD. Because you can get some performance out of those things.
For sure.
So, yeah.
How reasonable is it to plan some UDP for zero trust? Like how bad would be packet lost in the context of zero trust?
I don't know that those are necessarily super related. So you can when you're on top of the overlay itself. So we actually do TCP connections between routers, but the data gets repacketized on top of the overlay. So it's not like a connection between endpoints goes across the overlay. It's basically taking all of the local loops from each end of the... So you've got the overlay, you've got the endpoints. They each have their own connection to the overlay. And then the data that goes across the overlay is packetized again at a higher level. So it actually acts like UDP across the overlay, which is part of how we avoid... One of the things people often talk about is if you're going to sort of tunnel TCP through another layer that's more or less TCP, you end up with weird effects with flow control and those kinds of things. We avoid that by repacketizing the data.
And is data loss that can happen with UDP a problem?
No, because I mean, all of these things have the normal kinds of flow control and retransmission and all the things that you would expect to have in any sort of packetized network. Yeah.
So basically, it's solved on another layer, kind of making sure that this is consistent. I see.
Yeah. So the overlay if you send a packet across the overlay, it's guaranteed to arrive just like a TCP connection. But that may actually incur packet loss that needs retransmission and some of that sort of stuff.
All those trade-offs.
Yes.
Okay, so UDP is your favorite protocol.
I would think so. Yeah. To me, it feels very pure and like
a lot to do with like Play-Doh.
Yeah, to me, UDP is sort of, datagrams. That's the internet.
Okay.
Yeah.
Then I will ask one more question as we are moving into the unpopular opinions.
Unpopular opinion. I actually think you should probably leave. Unpopular opinion.
So do you have an unpopular opinion on any topic at all? It doesn't have to be on packets or on protocols.
I have a lot of unpopular opinions. I feel like I have an unpopular opinion. My unpopular opinion is I think we're going to look back at some point in the future, let's call it 10 years, 15 years, and this whole model of content and things being shared or things being hosted by somebody else for the sake of convenience, streaming, whatever you want to call it, will flip back around. I think we're going to move back to a world where I can own a piece of content and curate it and manage it myself. I feel like it's sort of a fundamental human thing to want to collect things and curate collections and build collections. And I think the world we live in right now, where everything is sort of streaming, doesn't really support that very well. I mean, it's very common. You might fall in love with some TV show and all of a sudden it's just gone. That I think we're going to move back to a place at some point where I don't know how that'll look technically or how that'll work socially, but I think we'll move back to a place where you can sort of say, I own this thing. And I think that's an unpopular opinion.
I saw an interesting startup that does something a little bit similar in some way. Let's say it reminds me of that. You as an artist, you upload images or something that you do, and then people can generate images in your style, and you get the royalties for that. So that sounds like a relative of this concept.
Yeah. I mean, personally, I kind of wish there was if you're familiar with Bandcamp, I walk this walk. Like I have huge collections of media that I curate and I own. I still buy CDs and I still buy a lot of music from Bandcamp because I like to download it and own a copy of it. I kind of wish there was something like Bandcamp, but for movies, where I could I don't necessarily care about owning a Blu-ray, but I'd love to own the highest possible quality copy of like my favorite film and be able to legally, download a good copy of it. Like that would be fantastic. I'd be a huge customer of something like that.
Interesting. I think I will disagree with you here. I don't mind having this just as a on demand, and I'm also not the person who watches the same movie twice. So
sure,
maybe I'm not even in the focus group anyway. But it's a good start for an unpopular opinion. Yeah.
Yeah. No, I figured that would be a very unpopular opinion.
I have an unpopular opinion that I'm still trying to phrase on this field. So I'm mostly agreeing with it, but maybe I'm still not fully agreeing with it myself. But zero trust is a little bit like a trust issues. So if you want to have practical trust issues, maybe you can learn something from the fundamentals of zero trust. But maybe it's a bad idea. Let's see. Maybe I will vote against this when this becomes a poll on Twitter as well. Well, that was educational and interesting. Thank you for answering all the many questions, and thanks
Sure.
for a great conversation on networks as well while at it.
I really enjoyed it. Thank you for having me.
And all the many tools and links and repos that you mentioned will all be in the show notes.
And we're all real people, so feel free to reach out, and like we're on GitHub and we're very, very reachable. So
Thank you very much, Michael.
All right, that is go time for this week. Thanks for hanging with us. Subscribe now. If you haven't yet, head to gotime.fm for all the ways. And of course, connect with us on the socials. We are GoTime FM on X and GoTime at changelog.social on the Fediverse. Thanks once again to our partners, Fastly.com, Fly.io, and Typesense.org. And to our beat freak in residence, the mysterious Breakmaster Cylinder. That's all for now, but we'll talk to you again next time on Go Time.